How do you go viral while making space videos? By making science accessible. This week on Planetary Radio. I'm Sarah Al-Ahmed of the Planetary Society, with more of the human adventure across our solar system and beyond. This week I sit down with science communicator and content creator Kobi Brown, better known online as AstroKobi. I've been one of his fans for a long time. We spoke in person at the Planetary Society's headquarters about his journey and the future of space communication. Then we'll hear from Jack Corelli, the Planetary Society's Director of Government Relations, for a critical space policy update. With the nomination of Jared Isaacman for NASA Administrator moving on to its next step, and a proposed 47% cut to NASA's science budget looming, there's a lot at stake for the future of American space exploration. And of course, we'll wrap things up with What's Up with Bruce Betts. If you love Planetary Radio and want to stay informed about the latest space discoveries, make sure to hit that subscribe button on your favorite podcasting platform. By subscribing, you'll never miss an episode filled with new and awe-inspiring ways to know the cosmos and our place within it. Kobi Brown, who's better known online as AstroKobi, is one of the world's most popular space-focused content creators. Since launching his channel in 2022, he's amassed over 5 million followers and billions of views, making complex topics in physics, astrophysics, planetary science, and cosmology accessible to audiences around the world. Kobi is based in Australia and holds degrees in physics, astrophysics, and applied mathematics. But it's his infectious enthusiasm for space and his signature soothing voice that have captured hearts worldwide. In just a few years, he's gone from uploading short videos online to collaborating with NASA, ESA, Google, the Planetary Society, and more. We sat down together at the Planetary Society's headquarters while he was in town filming with Bill Nye and preparing for his very first visit to NASA's Jet Propulsion Lab. From growing up under the dark skies in rural Australia to walking beneath the Large Hadron Collider at CERN, this conversation is a reminder that science communication can change lives, and sometimes even entire career paths. Hey, Kobi, it's wonderful to meet you in real life.
Thank you so much. I'm so excited to be here.
This is a trip for me because I've been following you on TikTok for, a little over 2 years. But I believe your journey online started, in 2022? Not that long ago.
Something like that, yeah. I started posting on social media, just talking about space and the universe. Yeah, when I was in my second year of my undergrad, actually, in sort of the middle of 2022, it coincided with that big release of the EHT collaboration's Sagittarius A-star image. I posted a video all about that, and then it took off, and the rest is history.
That's wild. Were you planning on going into science communication when you were getting your degree, or did it just kind of spontaneously emerge from that moment of science communication and how it impacted your life?
Not particularly. I definitely wasn't planning on a career in science communication. My career trajectory at that point was just to continue studying and doing research and finishing a PhD and stuff like that. And then, I sort of just fell into it. And then equally, I've always been interested in science communication. I love the work of, the classics like Neil deGrasse Tyson and Bill Nye and all the others. So I very much fell into it, and I sort of just ran with it.
I grew up in a time where the biggest examples of science communication for me were, Carl Sagan, Bill Nye, Neil deGrasse Tyson. But in that early age of YouTube, there was a whole new generation of science creators. And I've read online, although I'm not sure if this is true, that you actually fell into that group. You fell into that group of children that were watching these channels online. How did that shape your experience of science learning?
Honestly, this is true. I've said it a few times before that I think I was a part of that first generation of kids who I just loved YouTube. I'd never watched TV or anything like that. And I was just a YouTube kid and just so happened to stumble upon, videos made by the biggest science communicators back then, the Veritasiums and Vsauces and Physics Girls and all of those people. And I think at that age, when you're 10, 12, 13 years old, I think your brain is sort of primed to really attach to something. And I think that's what Bill Nye said with his show. The thought process was, if you get these kids excited about space and science at that age, it instills that in them for the rest of their life. And I think that's ultimately what happened to me. And I attribute a lot of the reason why I'm in the position I am today to those people. especially because I grew up in a rural town in Australia where no one was a physicist and no one was an astrophysicist. And my exposure to that was essentially exclusively through YouTube and through documentaries.
But also through the beautiful view of the sky from down there. I mean, you get to look up and see the Magellanic Clouds. The first time I saw that in Australia, it blew my mind.
Yeah. I mean, I definitely took that for granted, especially growing up in a relatively rural place under dark skies essentially my whole life. And then moving to the city, I noticed a very stark contrast. And I sort of, realized how fortunate I was in that sense. And that definitely sparked the same interest as well in me. I remember I would sit outside when I was 10 or 12 years old with my little telescope that I didn't really know how to use. And I would try look at stars, but it would never quite work out. And then I'd just end up eventually just pointing it towards the moon because that's easy. And I'd look at the craters and then, I don't know, something about the fact that Galileo, when he, perfected his first telescope and pointed it towards the moon and saw the same things. He saw literally the exact same craters that I was seeing. I think something about that, the connection through time that astronomy brings you was like a big sort of key moment for me, for sure.
Really wonderful feeling that connection to all the people that came before, but also what a wild time to be a science communicator with all these missions going on and with so much international collaboration. Now is just this really unique time where I feel like there's more going on than ever before. So we need more science communicators to explain it, which is why I'm really glad that there's a large generation of people that are getting into this. But I think you've done something really special in that you started your channel not that long ago and somehow managed to blow up every single social media platform to over 2 million followers. How did you do that in such a short amount of time?
I think ultimately it comes down to what I set out to do, like my goal. My goal was, and still is, to make these things that I find like inherently, truly, really interesting and amazing, help other people understand that. I think often today, some of these really technical subjects can feel to the average person like a monstrous task and something that they'll just never be able to understand. And I just thought that wasn't necessarily true. I thought there's absolutely ways, and because people do it, like people find ways to communicate what you're like you're saying, what we're doing in space science right now is so amazing. And it's like there's never been a time before where we've even been, remotely doing as much. And so I think, setting out with that goal really helped as my sort of North Star to, make these things that I know are inherently beautiful as accessible to as many people as possible. I think that was the really key in my sort of explosive growth, because the average person would be able to hopefully watch and enjoy and learn something when, if I would have made it more targeted at people with a scientific background, maybe it wouldn't have reached enough or as many people.
That's true. Plus, we're also steeped in this, right? I mean, when people ask me why I got into science communication and why I forked away from doing research, it's not that I didn't love the research, but there is nothing on Earth that rivals that look in a child's eyes the first time they realize they're made of stardust, right? Being able to communicate these things to people that haven't been exposed to them before, just that moment of sharing is really what empowered me to do it.
Yeah, no, I completely agree. It's when I look in my comments and people have had that sort of click, eureka, aha moment where something's clicked for them. I know what that feels like. I know what it feels like to watch a YouTube video and realize something that's beautiful and elegant that I didn't know before. And I think having experienced that feeling, the fact that I get to do that for other people today, I find, really like fulfilling and really, really valuable.
What's the science communication scene like in Australia? Because I've met a few people that are big name science communicators, but the United States is kind of overflowing with people. So I'm curious what your experience has been like.
I think it's growing, and I think relatively speaking, we sort of punch a little bit above our weight class. Like there's not many people in Australia, and a lot of the people studying these things, like at my university, my class is filled with 10 people, while over here in the States, you're right, there's just so many people who talk about and think about these things. So it's definitely growing, and there are some really amazing science communicators doing some really big things. I just think it's just going to have to grow further.
I wonder how much of that we can attribute to the size and kind of commitment to the space agencies in each country. Australia does have a space agency, but it's just kind of getting started. They've got some cool projects coming up, like the Rover, for example. But have you had any interactions with the Australian Space Agency?
Yeah, I did a big sort of campaign, sort of with the Australian Space Agency and Lego Australia when they launched a big Lego space campaign. I essentially worked with them on that. And that was the first time I really got to know the people from the Australian Space Agency. And you're right, it's a small team, it's very like grassroots, and it's still starting up. And I think part of what contributes to that, in contrast with, America and other places, is a lot of the people I meet here grew up hearing so much about space and very much it was a part of their everyday life. Like lots of people have seen rocket launches and people grew up in the Apollo generation and through Voyager and the space race and everything like that. It was a very focal point in sort of the average American's life. But for Australians, it's not really like that. And I think a lot of people that I've met throughout Europe and other places still do resonate with that. But I do think times are changing with access to education and information flow online. A lot of these things, this space field becomes more accessible and people get access to it more, which is why we see, space agencies in places like Australia and New Zealand and Europe growing so much more and so much faster than they have in the past.
As soon as people have the opportunity to see themselves in that job,
of
right?
course, literally, yeah.
Yeah, and then suddenly you can see a pathway through. I feel very lucky that I lived in a time and place where I felt like that was a career I could actually pursue. Hey, I didn't end up at NASA, but I still found myself a space job. But I think about all of the people out there, all of the children, all of the educators that wish they had that opportunity. And I think that's part of why this movement toward social media science communication is so useful. Even in the times when I couldn't find my space job of my dreams, because let's face it, sometimes you find an awesome job, but it doesn't put the food on the table, right? Of course. I, too, was about to fork into social media science communication when suddenly my job from the Planetary Society fell in my lap, right? But I think science communication online is this place where people can really get their names started. And maybe that's where they stay. Maybe they find another career, but until all those jobs are available, I think that's a really great place for people to find their space legs. Yeah,
you're right. I mean, it's ultimately about visibility, but equally as well, I think it's about, bringing a lot of this stuff down to earth. People think working in space, you have to be this brilliant genius and you're an aerospace engineer or like the next Einstein astrophysicist. But space is a big place. There's lots of people. I spoke about this with Rosemary Coogan, she just finished her astronaut training with ESA, and she's now qualified to go on ISS missions. And she sort of made a good point that, a few years ago, the average person wouldn't have known that working in space can mean you work in law or you work in communications or you work in hospitality. There's infinite ways to work in the space industry and contribute to these things that people find interesting. And I think without social media and a lot of things like that, that information just isn't out there as much.
Well, you're from Australia, but your largest audience is actually here in the United States.
I would attribute most of it to population, right? Americans, there's 300 plus million Americans, and in Australia it's 25 million, something like that. So of course, just the raw number of people who I would have access to seeing my videos is going to be drastically different. But ultimately, I think American social media, the industry is much more developed for something like professional science communication, where it's seen as a career and things like that. I think naturally in Australia and some other countries, it is still catching up in that sense.
You started with YouTube, right? How did you go from there to expanding into all of these other channels?
So I started with short form video. That was the key. I started with short form. I posted on YouTube Shorts, but equally I just post them on TikTok and Instagram and Facebook and everywhere else, just because why not? Like I've got the video, so why not post it everywhere? And then when they started taking off on different platforms, my ultimate goal was to leverage that for my YouTube long form content. I think that's where a lot of the business of being a creator lies, and a social media communicator, a lot of it lies in long form on YouTube. But equally, that's just where my passion was. I found that funnel of use the short form to get people interested and then use the long form to help them deeply understand the topic, really useful. And the feedback I got from it was overwhelmingly positive. So that was, I guess, essentially the plan.
But now that you've expanded into this, you're on all these adventures. I mean, right now you're in our HQ filming some stuff with Bill Nye.
Yeah.
What other cool adventures has this taken you on?
It feels like it's just getting started. I just got back from Switzerland where I visited CERN, which was
cool.
Yeah,
I want to go there.
A long time goal, bucket list item of mine, and yeah, I couldn't believe the things I got to do and I was able to see, especially because 18 months before I was in the LHC tunnel, walking around underneath the biggest particle accelerator in the world. I was learning about that exact same experiment in my particle physics class at university. And that contrast in 18 months from, writing research reports on it to walking around underneath the Atlas experiment that, weighs more than the Eiffel Tower and it's buried 100 meters underground was one of the most surreal experiences ever. And then you're right, I'm here with Bill Nye that I watched when I was a kid, and I'm going to JPL tomorrow to play with the Mars rovers. And it's just, it's a crazy, crazy experience, everything.
Have you been to JPL before?
Never. I've never been. Tomorrow will be my first time, and it feels like they're giving me the full tour. It seems like I'll be able to play with the Mars rovers and look at the sample return mission stuff and then go in the clean room and all the very exciting things. Yeah.
Oh, I'm so excited for you. The first time you go to JPL, anytime you get to step into these science institutions is wild. But being someone that lives right by JPL, make sure you ask them to see the cool tubes that show the downloads from the Deep Space Network. It's
I will.
So cool.
I'll ask.
So you've been on all these adventures. What people have you met along the way that you feel have really impacted you or maybe have changed the way that you've communicated science to people?
The obvious answer that jumps to my mind are a lot of the other science communicators and industry professionals and academics that I've met. I think learning a lot from them about how they view their work really shapes how I go about what I do, especially the academics, that in some ways it's a very draining career. It ultimately just is. You spend a lot of your time doing teaching, which you might not enjoy, or you spend a lot of your time doing paperwork and writing submissions for, you understand. It can be draining, but ultimately what drives them, and it seems pretty unanimous with a lot of these people, what drives them is a deep goal and a deep affection for understanding the universe and wanting to understand how things work. Regardless of all of that noise, that's ultimately what it comes down to. And I think that meeting those people and hearing how unanimous that consensus is in these fields strengthened, I guess, my mission. It really strengthened my idea that this is what I want to be doing and what I enjoy and what brings me joy. And then other than that, it was also meeting a lot of people that have said that they've seen the videos and they say it either got them interested or now they're pursuing physics or they're going down that pathway because they've seen just, me talking about JWST images or something like that. It sparked something in them. Hearing from people like that always has brought a lot of joy to my life, for sure.
Isn't that wild?
Yeah.
I mean, I never imagined as a science communicator that anyone would ever recognize me, let alone hear something I said and then decide to change their entire life to pursue science or go teach people or go on trips.
I completely agree. It's easy to get caught up in numbers, right? I see my video gets 1 million views, but it's hard. I mean, it's impossible really for the human mind to conceptualize what that means. That's 1 million individuals looking at you talk about this subject, but it's the real life stories that we're talking about when someone tells me that they were going down a path and have always loved astronomy, and then watching one of my videos sort of instilled confidence in them to change the trajectory of their life and sort of go down pursuing their passion. It's those stories that both shock and inspire me, for sure. Right?
You're going to be the next Vsauce or Veritasium for that next generation.
That's a crazy thought to think, because that experience is so vivid in my mind. Like I was that kid that would watch the Vsauce video and then go to school and try mentally rehearse it to my friends because it make me feel like so smart and that's so cool. I'm like, oh, I love this interesting information. And now I can, in a way, get to be that for other people. And that's a very surreal experience, but it's equally, because it's so vivid in my mind, it's a pretty crazy thing.
What are some of your favorite things that you've gotten to speak about on your channel?
I think the thing that initially jumps to my mind is exoplanet astronomy. I really, really love exoplanet astronomy, and I was essentially going to be going down that path if I wasn't doing science communication. I would have done my PhD in exoplanets. And so I think a few of the videos I've made about how that science works and how the field is evolving have been some of my absolute favorite videos I've ever made. And fortunately, it's such a growing field that like there's exciting things coming up that I'm doing that touch on that as well. I'm going to meet with Sarah Seeger at MIT to talk about both the Solar Gravitational Lens Telescope mission as well as Starshade, which are these two very beautiful, they're elegant and beautiful missions that they're trying to get through to give us the first really, really clear images and data of exoplanets, of worlds that are orbiting other suns just like ours. And I think these are the ideas that got me hooked into astronomy as a child. And so, of course, making videos about them brings me a lot of joy.
For people who aren't familiar with the concept, I think we've spoken on this show maybe a year and a half ago about the idea of using the sun to allow you to see other worlds more closely. But how does that work?
Yeah, it's when I say it's a beautiful and elegant concept, I mean that because there's an effect, thanks to Einstein's general relativity, where we know that massive objects bend space-time, and that includes, it warps the path that light rays can take through space. We see this around really massive objects, black holes, more strikingly, but it's also true for, relatively speaking, small objects like the sun. And so the idea is if you send a telescope really far away, I think it's around 300 AU.
It's really far.
So really, really far, and you position it in just the right spot and have it sit there, you can use this effect. You can use this gravitational lensing effect that the sun will have to essentially zoom all the way in and get really, really clear, refined data, both spectroscopy and optical data from these exoplanets. And it's one of the, it's essentially the only way that we could possibly get really up-close shots of distant exoplanets around their own star.
But how do you deal with the fact that the sun is the object that you're basically staring at? How do you subtract that out of the data so you can actually see the exoplanet way in the distance beyond the star?
Yeah, so there's a few different ways that they're essentially trying to solve that problem as well. The most, obvious one that has been tested is these coronagraphs, right? So in JWST, you sort of within, just before the optical part of the telescope, you'll block out a bit of that sunlight, but it's not as effective, and it's not that great at giving us really, really high fidelity clarity on that yet. And so that's part of what I'm chatting to Sarah Seeger about, is this Operation Starshade, where you send out a telescope and this beautiful, I don't know if you've seen the animation, but this beautiful sort of sunflower that they'll send out into space. And it looks beautiful, but it's also, this sunflower shape is very intentional, and it works to exactly block out the light from that star to some sort of ratio between the darkness of the blocked starlight and the light from the exoplanet. The ratio is something like in the billions. It's a crazy, crazy figure. And so this is a really, really amazing way that we might be able to do that as well. And it would give us really, really clear spectroscopy. That's the main thing, compared to something like JWST's coronagraph.
The really challenging thing is, how do you get it out there at that distance and keep it in place? That's going to be tricky, but maybe a combination of solar sailing with some onboard little jets or something. I'm sure we could figure it out.
It's tricky, and that's because I'm diving deep into this right now. I had the same thoughts. I was like, how do you possibly, because they're not close together. This Starshade and this telescope, you'd have to fact check, but I think they're millions of meters and they're very, very, very far away from each other, essentially. And you need to keep them lined up to a degree of precision that's on the order of centimeters. And that sounds to me like a near impossible, crazy task. But people at JPL have made scale models and tested it across these big desert sort of salt lake beds. And at least as a very scaled down tech demo here on Earth, have showed that it's at least relatively possible.
It's never been a better time to be someone who's into exoplanets.
Yeah.
But exoplanets are something that I think people can tangibly relate to because they live on an actual planet.
Yeah.
The thing that I really wanted to explain growing up to people was the weird, quirky physics parts of the universe. But that's uniquely challenging when it's something that isn't within someone's everyday experience. So how do you go about trying to explain those more complicated subjects in physics and cosmology?
I think for me, it's a lot about the storytelling. I think storytelling helps in that, because that's just what worked for me.
Yeah.
When I would watch videos or even in lectures, when people would ground a lot of this physics in the stories of it and who these people are doing the work and I don't know, what their lives are like, and then equally what the story means, like what finding an exoplanet that's a little rocky world that has water on it, what that means for us as humans and for humanity. It's that storytelling that keeps people engaged, I think. And as we were saying with the exoplanets, I think that's why a lot of these newer missions are so exciting. Because like you said, historically, a lot of these methods we use to look at exoplanets, whether it's radial velocity or transit or even direct imaging, they're all very biased towards very massive objects that are very close to their stars.
All hot Jupiters.
Exactly. You just find these massive, massive planets. And while that's beautiful and interesting, I think there's just something about when you find, the TRAPPIST-1 system where it's these little rocky worlds and they're in habitable zones and things like that people find a way to relate to and let their imagination sort of run wild. And I think that's what gets people really, really engaged, which is why, I'm so excited about a lot of these new missions that give us more data and more access to, I guess you could say these storytelling tools.
How do you go about picking what things you want to talk about? Because we do have this issue between talking about the cool things that have already been established and leaning more into that news-based, what's hot in media kind of tactic. Where do you fall on that spectrum?
I think you need to find a bit of a middle ground, especially when it honestly feels like lately with that news tactic type stuff, a lot of what my job then becomes is in some ways like de-escalation and clarity. It's really interesting. This stuff's really interesting, but the stuff that tends to make major public headlines can be misconstrued. And so in some ways there needs to be a level of that. And you need to be able to communicate why this thing is still really interesting, but you shouldn't be confused or you shouldn't be misled. And then equally, on the other extreme, I think I really like to explore ideas that aren't super trending, but they are because they are the ideas like this that I find really beautiful. Things like exoplanets and black holes and general relativity as a whole. I find them to be some of the most beautiful but misunderstood ideas. And so I kind of just have a list. I have this massive list of stories I want to tell. And so it's just about working my way through that list, essentially.
Yeah. My list is so long, I'm going to be at this just as long as Matt Kaplan, my predecessor,
Yes.
like 20 years minimum in order to get through all the things on that list. We'll be right back with the rest of my interview with AstroKobi after this short break.
Greetings, Bill Nye here. The U.S. Congress approves NASA's annual budget, and with your support, we promote missions to space by keeping every member of Congress and their staff informed about the benefits of a robust space program. We want Congress to know that space exploration ensures our nation's goals in workforce technology, international relations, and space science. Unfortunately, important missions are being delayed, some indefinitely. That's where you come in. Join our mission as a space advocate by making a gift today. Right now, when you donate, your gift will be matched up to $75,000 thanks to a generous Planetary Society member. With your support, we can make sure every representative and senator in D.C. understands why NASA is a critical part of U.S. national policy. With the challenges NASA is facing, we need to make this investment today. So make your gift at planetary.org/takeaction. Thank you.
Where are you seeing your channel going in the future? You've laid a really solid foundation, but now that you've got that and a team, sky's the limit.
Yeah, I think I want to really double down on what's working and keep pushing the limits, I think. I really want to innovate what it means to be a science communicator on YouTube. It feels like that's been very consistent and it's worked for a long time. But I do think people, especially the new generation, like to learn and engage with this stuff in a different way. And so I think the space does need to evolve in a way. And so in some ways, I'm thinking about that. I'm thinking about, how I can build on this base core audience I've got, but make my content even more accessible to younger people as well as to older people. And what kind of formats work really well for that? Adding podcasts or expanding into really long form stuff where you do sort of feature-length documentary style stuff. I think there's space to explore that. And fortunately, I feel like I've got a good foundation and enough time to really explore each avenue entirely while I can, essentially.
It sounds like you're doing some really good kind of social listening on your channels.
Yeah.
What is your audience interaction like?
I think it depends. It really depends on each platform as well as what the videos are, and it depends on what's happening. I think overwhelmingly it's positive. People find my videos very interesting and they really like the way I explain things or however it might be. But at times when there's very volatile news, there can be a lot of confusion and people can find, I think they reach out in the comment section looking for clarity and looking for direction. And so it's kind of my place and other social media science communicators' place to provide them with that in those times, I think, yeah.
Yeah, it's really difficult. We see our numbers just skyrocket anytime there's some really sensationalist kind of headline, but it is kind of frustrating in that we do have to keep playing defense and not try to invalidate this passion people found for this headline. At the same time, it does us all a disservice. It makes people feel like they can't trust the science when all the people who are in science communication are trying to kind of course correct from some of these more misinformed kind of headlines and stories.
I get that. I think that's definitely true for the most part. But then at times it feels like there are these big events where the science really is as ridiculous and as amazing as it sounds.
It's true.
And then it feels like it goes nearly the other way. Everyone's so excited about it. I felt that JWST was such an exciting time, and people, the public that were completely not, interested in science content typically, was so interested and invested in it, as well as, the Sagittarius A-star image.
Right.
Those moments. And I think of course there'll be many more. Artemis is going to be a huge thing like that, where I think the average person will be so invigorated and excited by what's happening in the space science sector right now. And it's about leaning into those moments and really letting them breathe. I think that really helps as well.
Yeah, I had been waiting for JWST since I was a tiny, tiny child, back when they called it something completely different. It took so long for that telescope to happen. And because I was already working at the Planetary Society and in science communication, I got to be at JPL for the release of those images. But inside, I was just feeling this it's so important to me. This is so important to all the people in our space community. But what is going to be the public reaction? Because we're not in that Apollo age, right? Are people going to be engaged with this thing that scientists have been working toward for literal decades that's going to revolutionize our ability to look at the universe? And I was so heartened to see that, they put them up in Times Square. People were showing them as the backgrounds of their concerts. The videos on TikTok blew my mind. Everyone lost their mind. What do you think? I mean, you've spoken a bit about Artemis and that big moment, but how can we as science communicators try to get more people excited about these things on a daily basis? Or do we just have to wait for these monumental moments that are decades apart?
I think so much of it comes down to passion, the passion that you're expressing about how you know that this mission, this project took so long and so much work from so many people, and the results really are amazing. I think it's that passion that you need to show to people and try your best to really invite them into your world and like let them know why it's so amazing and why this is such a monumental thing and why they should care. I think if that's at the core of what you're doing when you're trying to communicate these ideas, I think that really shows. And I think people see that. I think it's a very human thing to see someone's passion. So I definitely try to keep that in mind when I'm talking about a lot of these things, especially when they're relatively hard stuff. I think there's a lot of really interesting research happening right now in sort of cosmology and the dark energy space with DESI. And I think some of that pending is going to be some of the most exciting and interesting science we've had in, I don't know, the last decade. And while it's really tricky to communicate something like that to people, I think showing people how passionate you are about it is a great place to start. It's easy for us often to look back at, general relativity and the quantum revolution and all of things like that and think, oh my gosh, like how amazing it would have been to be around during that sort of leapfrog in the paradigm shifts of yesterday. But I think people maybe write off, because we're living in it, of course, you write off the reality of today. We are investigating things that are just as groundbreaking and just as interesting. And we really are, especially with this Hubble tension stuff and many other exoplanet astronomy things, really are at the cutting edge and at the cusp of sort of things that could be as big as those, quantum revolution.
Right. If I had a time machine, I would go pick up
Exactly.
Einstein and Hypatia of Alexandria and just, Galileo and put them all in a truck and just take them to go see the things that we know about the universe. I think you're right. A lot of us just kind of take it for granted because we're in it right now. But people 100 years in the future are going to look back on this time and be like, wow, the age of discovery. They didn't know what dark energy was.
Yeah. I mean, that was part of my reaction when I was at CERN. I think in my video that I made all about it, I put in this clip where I had just come up from being 100 meters underground in this big 27-kilometer long tunnel where they collide particles at essentially the speed of light and create
so cool.
The most mind-blowing, they literally recreate the conditions of the Big Bang on Earth in Geneva. And I came up from all of that and my mind was completely blown. And I think I just said to the camera that I would give anything to be able to go back in time and bring back, Bohr and Heisenberg and all of these people and just show them what we know and show them what we've achieved with the foundation that they laid. And I think that would do everyone a lot of good to see how truly mind-blown they would be by all of it.
Absolutely. Well, it's been wonderful seeing your journey over the last few years, and I just know that you're going to absolutely crush it as you go into the future, and I'm really hoping that in 20 or more years, you're going to meet that next generation of people that tell you that you were their Vsauce, their Veritasium, because it's going to happen.
Yeah.
And I bet it's going to blow your mind.
I hope that my mind gets blown. And I really hope that, I really value what the Planetary Society does. And I really believe in the mission. And so I equally am inspired and really grateful for the work you guys do.
Thank you. That means a lot. I mean, I was starstruck meeting you, and it's wonderful having you in this impromptu moment in our HQ. And I hope you've had a beautiful time here. I have. I've had an amazing time, and I can't wait to come back. Well, until next time. Thanks so much. Thanks so much. It's always inspiring to meet someone who's using their platform to spark curiosity on a global scale. And I can't wait to see what Kobi shares from his first trip to JPL. There are so many wonderful, aspiring science communicators out there. If you're one of them, I hope that this conversation with Kobi helps you know that you're capable of doing it too. And all you have to do is share what you love with the world. Well, that and a thoughtful plan for how you're going to roll things out on social media. Now, let's shift gears and check in with Jack Corelli, the Planetary Society's Director of Government Relations. It's been a whirlwind few weeks in space policy. Jack's going to break down what's happening in Washington, D.C. and what it means for the future of American space exploration. Hey, Jack. Nice to see you again.
Hey, Sarah. Always good to see you.
Well, we just saw each other a couple weeks ago at our co-working week, so it's always wonderful to work with each other in person. But between the gala and everything else, we haven't been able to give people a space policy update in a couple weeks now. So I think the last big topic that occurred that we didn't get a chance to talk about was actually Jared Isaacman's nomination for NASA administrator. I know this is a little bit of old news, but we do have a big vote coming up. So I wanted to ask you how that situation went down and what is the next big checkpoint in learning whether or not he's going to be the next NASA administrator?
Yeah. So I think maybe we covered this a few weeks ago. So Jared Isaacman, who was nominated by the president to be the head of NASA back in December, finally had his confirmation hearing in front of the Senate Commerce Committee on April 9th. So that was like sort of the real beginning of that process in the United States Senate for actually considering his nomination to lead the agency. It was a 3-hour affair. Matt Kaplan and I did a live play-by-play that was a lot of fun, but that was a very interesting hearing. A lot of topics came up regarding, the future of the Artemis program, the future of science. This was notably, this is, around the same time that we started to get the confirmation of rumors of the 50% cut to science. And, Mr. Isaacman was very clear that he's not been part of the budget planning process and reiterated his support for the science programs at NASA, and in fact called for more telescopes, more rovers, more probes. Since then, one of the big things that has happened is he was, so in addition to sort of the live question and answer period that happens during a hearing, senators are allowed to submit questions for the record, which actually just today, as of recording this, we finally got those answers to those questions. They were released publicly. A lot of topics, again, I guess going into more detail on everything that I just described, talking about Artemis, future of the Gateway program is a big thing. A lot of senators pointing out the connection that their states have, especially non-traditional space states like Washington and Utah, which have a huge space presence, but don't have a NASA center, and so aren't necessarily thought of as space or as NASA states, but have a really robust industry there. So those questions very illuminating on where Jared stands on a number of issues, and again reiterated that support for science. Now we're on to the big thing happening next, which is actually a vote by the Commerce Committee to advance his nomination to the floor of the Senate. So nominees for a number of positions in government, including NASA administrator, have to be confirmed by the U.S. Senate. The Commerce Committee vote is the first step. Basically, it's the Commerce Committee saying, we recommend or we don't recommend this person to be the head of this agency or fill this Senate confirmable position. And so what happens next after that is a vote by the full Senate. All 100 senators, or at least the ones that are present, will be voting on the nomination of Jared Isaacman. And so we're looking at something in timeline of a couple weeks. This is also a non-traditional timeline for administrator. A lot of times these things are over and done with in the span of 20 to 40 days. It's now been over 4 months since Isaacman was nominated. And so we're already kind of in uncharted waters here in terms of timeline. So after this vote, actually happening right now as you're listening to this on April 30th, or a few days ago if you're listening to this late. So that is going to be indicative how that vote plays out. How many Democrats and Republicans vote for that nomination is going to be indicative of the level of support that he has in the full U.S. Senate.
Well, we'll see how that all goes down. I had a wonderful time watching the live stream that you and Matt did. It's always really fun to do these kind of play-by-plays and these really nerdy moments where we're all getting together to talk about space politics. But in the meantime, we still have this critical situation with NASA and the passed back budget, this proposed 47% cut to NASA's science funding. I understand that in the last few days, we've had a lot of volunteers on the Hill who are continuing to try to do the work to get more people into the Planetary Science Caucus, but also make them aware of these cuts. So what have you seen with volunteers in the last few days in DC?
It's been an amazing few days here in DC. So obviously, as of recording this, we don't have any further information about the status of the budget request. We just know that passback has happened, which generally it's a 4 to 6 week wait before you get the full budget after that happens. And so we're in the gray area, right? Of it could drop tomorrow, right? As we're recording this, there's a lot that is going to be happening in the next month. To prepare for that, these rumors are substantiated. Right. We can all agree that based on public reporting, these rumors of a 50% or near 50% cut to NASA science, this extinction level event, is strongly being considered and may be part of the final proposal by the administration. The Planetary Science Caucus, the bipartisan Planetary Science Caucus, I might add, were some of the first people in Congress to stand up and say that this is unacceptable and that we need full, robust funding for NASA science. That number is $9 billion. Seems like a lot of money for an individual, but actually is just slightly above the peak inflation-adjusted funding level for NASA science. This situation is warranting congressional action. And so the two co-chairs of the Planetary Science Caucus, Representative Don Bacon from Nebraska and Representative Judy Chu from California, are leading a letter, much like they did last year, openly opposing these cuts and saying that we need that full and robust funding for NASA science. So far, this letter, not just the signatories in Congress, which we're getting close to 40 right now.
Oh, wow.
It seems to change every day, so I don't even want to put a number, but it's getting close to 40. Maybe even by the time this episode's coming out, it's over 40, which notably we had 44 last year on this a similar letter, but has a growing list of endorsing organizations from across the space community, everybody from the American Astronomical Society and American Geophysical Union, and of course the Planetary Society, to organizations like Explore Mars, the Planetary Science Institute, which is a private institution that specializes in planetary science research. The Secure World Foundation and the Satellite Industries Association have also come out in support of this letter. University Space Research Association, the Space Development Steering Committee, Association of Public and Land Grant Universities, American Physical Society, and the Association of American Universities are all endorsers of this letter. It's an amazing laundry list spanning the diversity of the space community, from private institutions and advocacy organizations to scientific societies and trade associations. This is not just one community or another standing up and saying that we need this full and robust funding, but this is the space community. This is everybody banding together to say that this is an important endeavor for our nation and that they are encouraging their members of Congress. Now, back to what you originally asked about, which is the volunteers. So I had the honor of walking the halls of Congress in sort of an impromptu drop-in day. We hit up 250 House of Representatives offices, because this letter is only in the House. We're working on a Senate complement letter, but in the House, we hit up 250 offices with a near parity, 1-to-1 parity between Democrats and Republicans, because this is a bipartisan issue. And we did this in less than 2 hours. Our amazing volunteers, we burned a lot of shoe leather on Thursday, getting this message out and showing that, again, this is something that is supported by a wide swath of organizations in the broader space community, and that we need a strong amount of support for NASA science because it is facing a crisis moment. A 50% cut. NASA science has been, as a percentage of the NASA budget, has been going down. Looking at inflation-adjusted numbers, it's been going down consistently for the past 5 years. And last year, we saw some of the most significant direct cuts to the Science Mission Directorate in over a decade. And so right now, science is at a low point, and any further cuts, 50% or otherwise, will be detrimental. Obviously, a 50% cut I will say, would absolutely decimate the space science community and the space industry, which a lot of space industry relies on consistent funding from NASA. NASA is an anchor customer for things like the commercial lunar payload services. A number of companies help provide not just the launch vehicle, right? You look at your SpaceX's and United Launch Alliances, but also provide the hardware and help build the instrumentation on these missions. And some of them, almost near completed, like the Nancy Grace Roman telescope, are being slated for cancellation, potentially, in this budget request. And so, this is something that across the community is raising alarm bells, which is why we're seeing such an outpouring of support for this congressional effort. But what is at stake is the future of American leadership in space. And if we are to decimate NASA's budget, we are surrendering leadership in space. Full stop.
Well, as dire as the situation is, teamwork makes the dream work. And we have all of these organizations rallying together. And this has been one of the best years for advocacy that we've had, since we started tracking it. So I'm really heartened to see just how much passion people are bringing to trying to save NASA science. It's really, filling my solar sails with light.
Indeed. And just going back to what you just said there, this is seriously, it is April. And we've had more people across the United States from every state. I think we're missing one congressional district at this point. We've had people come out of the woodwork to support NASA science. It is, again, it's April. We've had the best year of advocacy since 2017, since we started tracking. And I wrote up, on New Year's Day, wrote up my list of goals for work. Obviously, I set the bar high. I wanted to beat our record from the past 5 years. I didn't know we were going to beat our record for the past near decade in advocacy, and it's only April. So your letters matter. The calls you're making matter. Your involvement, the shares on social media, the comments, the show of support, it all matters. It is part of this growing movement for our future in space exploration and space science. And so keep up the pressure. We got some stuff in the works. We're cooking. We got some stuff that you are going to want to be a part of. So stay tuned, planetary.org/action for our latest action alerts, but just stay tuned for what we got in the works.
Thanks for the update, Jack, and good luck as we continue to keep up the advocacy, and hopefully together we can save NASA science.
Thank you, Sarah.
Thank you to everyone that's been using our Action Center to speak up for NASA science. It's having a real impact, and a bipartisan coalition of people are speaking out on this subject. But we cannot stop now. As always, I'll leave quick links on this Planetary Radio episode page. If you live in the United States, it only takes a couple of minutes to fill out the form and send those letters out so that you can help add your voice to the cause. But now it's time for What's Up with Bruce Betts. This week, we're talking about direct imaging of exoplanets. Hey, Bruce.
Hey, Sarah.
It was really cool getting to meet AstroKobi this week. I don't know how many online space influencers you follow, but I had a moment where I was going to the office and I saw someone in the parking lot and I was like, is that AstroKobi? No way. And then I got into work and it turned out that that's exactly who it was, parking in our parking lot.
Well, it's a funny way to do things. Yeah.
True. But I have really enjoyed seeing this new generation of science communicators online that are finding new ways to reach people. And this guy has managed to go from zero to a huge audience really quickly. So it was fun getting to meet him. But one of the topics that we did kind of discuss during our conversation, among the many, was how excited he was for all of the new technology coming out that's going to help us directly image exoplanets. And I know that's a really difficult thing to accomplish, but it could be really cool for the future. So why is that such a challenging thing to tackle? And how do you think we can actually accomplish this?
Two basic, simple concepts why it's hard. One, these are really far away, making them very tiny. And two, a bigger problem these days with big telescopes is that even if you could see their light, you've got a star sitting right nearby, which is much, much brighter. And so being able to image a planet is very, very challenging. And so there are ways we've done it, but typically it has to be a very large planet, Jupiter sized, out, distant, much farther out than Jupiter from its parent star. And then with Hubble, with other big ground-based telescopes, sometimes you can convince yourself that there's a planet there. Now with James Webb, you're doing even better. But the first key that is being used are coronagraphs, which is basically something that it's like putting your hand up to block out the sun, except they use something else in the optics to block out the starlight and then look for the planet next to it. And that's still quite the challenge, but it's the way we've done it and made more progress. But that's why people have had to be so very creative at finding planets in other indirect ways. We've found very few using direct method. But there are future technologies that are very intriguing, but very challenging to do, like taking a shade up and putting it in just the right place, this flying thing that you have to put between your telescope in space and the object you're looking at, and people are looking at doing that, and then you can do even better. It's basically a chronograph, but you're doing it in a fancier, more challenging way. Optical interferometry, if you could ever master that. I mean, that you can do that now, and like the Keck telescopes in Hawaii do it, and you can get higher resolution, but it's still very, very challenging, and to do it in space is challenging. And then you've got even more exotic things like taking a tin can and sending another one to the planet and having like a string between them. So that's actually very hard to implement, it turns out. So
Turns out.
I'm
Just
sure
scream
I missed
into a tin
things.
can like, do you have an atmosphere? And wait for it to answer.
Yeah, exactly.
I know it's complex to do something like this. And he did bring up things like solar gravitational lens missions. There are some
Yes.
more complex technologies we could try to do, but a lot of them are further out. But I just imagine what kind of impact that would have on society if we could take images of other worlds.
Hey, do you want to hear more about other things?
Absolutely.
Would you be interested in a
Random space fact.
Okay, let's get on to it then. Asteroids. They get discovered a lot now. There are more than 1 million asteroids known, something on the order of 1.2 million, most all of them in the main asteroid belt. But it was really slow early on. So the first asteroid wasn't discovered until 1801. The first 4 were discovered by 1807. Then there was like this huge gap until the 1840s when they discovered another one. And then eventually we got photographic plates toward the end of the 1800s, and then it started to ramp up. And then we got into the hundreds, and then we got much better at it in the last 20 or 30 years. But I just think it's interesting how slow the process was to start doing that. I'll throw a little bonus fact in. Vesta, because of its surface material and its size, is the one that you can argue you can see with just your eyes if the conditions are right and it's nice and dark, and it's pretty much the only one, unless you have one flying by very close to Earth and making life exciting.
It's really intense that people figured out that asteroids even existed at all before we had some kind of plates to record their position, right? I mean, watching them change
definitely.
against the background is the way that we do that typically. So even just
Right.
recognizing that thing's weird, they must have, I don't even know how they would have done that.
Patience.
And an encyclopedic knowledge of everything in the night sky.
Yeah, that too. And writing implements and drawings and patience,
Lots of patience.
luck.
Sitting in the cold, staring at the stars. That actually sounds a little bit more chill, more fun.
Yeah. All right, everybody, go out there, look up the night sky, and think about dartboards and how the Earth must look to one of those asteroids coming in. Thank you, and good night.
We've reached the end of this week's episode of Planetary Radio, but we'll be back next week to discuss how we analyze the atmospheres of subneptunes, the most common type of detected exoplanet. If you love the show, you can get Planetary Radio t-shirts at planetary.org/shop, along with lots of other cool spacey merchandise. Help others discover the passion, beauty, and joy of space science and exploration by leaving a review and a rating on platforms like Apple Podcasts and Spotify. Your feedback not only brightens our day, but helps other curious minds find their place in space through Planetary Radio. You can also send us your space thoughts, questions, and poetry at our email at planetaryradio@planetary.org. Or if you're a Planetary Society member, leave a comment in the Planetary Radio space in our member community app. Planetary Radio is produced by the Planetary Society in Pasadena, California, and is made possible by our members who love space so much that they want to do something about it. You can join us and help support space science and exploration at planetary.org/join. Mark Culverta and Ray Paoletta are our associate producers. Andrew Lucas is our audio editor. Josh Doyle composed our theme, which is arranged and performed by Peter Schlosser. And until next week, Ad Astra.